So this is where we started from. So we are asked to find the area of this resulting surface that will result from revolving this curve about the x-axis. So we know this just gives you a clear picture of what you're doing, but it's not needed to show when you're working out, as long as you know the formula. Okay, but it gives you an idea of what limits are you using. Look, if you remember how we used to calculate volume of such solids, we would say, can we make some disks out of this solid? So if I begin making disks here, they'll be going in this direction. Okay, so I see that I'm making my disks along the y-axis. So I'm using the limits for y. So you will notice that if you revolve this about the y-axis, so the curve will be in that way. So you'll be making your disks along y. So you are using y limits. But in any case, this is the formula that we used. We said, so since the curve is given as y is equals to f of x, which is y is equals to root x, we are just going to use this formula. 2 pi, this 2 pi is because we are saying the surface that we are getting is going around. So we can use 360 degrees. That's why we are multiplying by 2 pi here. So the formula is 2 pi, then y, which is the function you are using, then this is the formula for arc length. We already discussed this in our previous topics. But if you are new, this is the formula used for arc length. You say 1 plus y prime squared dx. Then we simply had to replace where there's y, we put root x. And this is where we came. And then we calculated what is 1 plus root y prime squared. When we simplified, this came to be this. Then we took the square root, which means rules of indices allow that we can take the square root of the numerator and the square root of the denominator, which is very smart kind of thinking, because you want to cancel out the root x, which is there, which is giving you a problem if you want to integrate. So we saw that this cancels that, and the 2 also will cancel with the 2 there, having an easier integral, which is simply that. Then what I did here is I realized that the derivative of this for the inside is simply 4. So I can introduce a special one, which is 4 over 4. You agree that this here is 4 over 4. But yes. I want to remove the 1 over 4 outside, and the 4 should go inside because I want to make use of it. Then I can simply use u substitution and let my u to be the inner part. I'll see that when I do the derivative, I'll get 4 dx, which is now here, 4 dx. When you replace in terms of u, your integral will just become u, square root of u. We know how to integrate square root of u. That will simply be 2 out of 3 u to the power 3 over 2. Replace back your u, you get that. Then we take the limits. I think this is where we ended. We take the limits from 4 to 9. You know, you use the rules. Fundamental theorem of calculus says upper limit minus lower limit. So we take the upper limit. When I put 9 here, I'm going to get 37. This will simplify to 37. But I'm taking the square root because this is over 2. Then I raise that to power 3 using rules of indices again, or rather rules of surds. That will simply be 37 root 37. Unless you want me to show you how this comes about. We are simply saying 37 root of 37 raised to the power 3. You know that this is the same as, I can bring down the 3 here so that it is root of 37 to the power 3. Again, root of 37 to the power 3 is the same as square root of 37 raised to the power 2 times 37. I don't know if that's clear, but I think you're getting the audio at least. So what will this simplify? I know that, again, I take this, the surds, rules of surds, that would be root of 37 squared multiplied by root of 37. And this is what comes to be, I know that here is going to be 37 root 37. Same applies to this part. And that will be your final answer, by the way. So we can end here. Unless if this can simplify further, you can do that. But I don't see anything simplifying.
All right, thank you.
Okay, let's go to the next question. I think I took my time explaining that. So let's pick another question which came from an exam. So let's pick this one. 3C, this one here. I don't know if there are people in the waiting room, but I'm not seeing anyone here. Okay, so question 3C says, calculate the area of the surface formed by revolving the graph of f of x equals to x squared on the interval 0 to root 2 about the y-axis. So this was 5 marks. So this came from an exam for 2019. Okay, is the question clear? Can we go to the solutions?
Yes.
Okay, so again, we just check our function. In this case is f of x equals to x squared. And the interval given is 0 to root 2. So if I give you an understanding of the sketch, that is 3C. So we know that the sketch of x squared is an easy function. So we have this function y equal to x squared. I don't know if it was given as y. It was f of x equals to x squared. So this is the, now we want to, the question is, where are we rotating? About the y-axis, right? Okay, so if we rotate this about the y-axis, can't you see that this is already rotated about the y-axis? It is already rotated. So you just see that you are forming a solid like that. So this is y. This is x. But we are talking of from 0 to root 2. So when x is root 2, what would be y? Hello?
2.
Of course, it will just be 2. So when we are here, we expect to reach 2 there on y. Okay, now look, if you start making those your discs as we used to find our volume in the previous topic, you will notice that your disks will be going along Y. So they'll be going in that direction. Okay, so let me put my 2 up there. So let's say it is reaching there, and that would be 2. Yeah. So we see that when we are making these disks, they'll be going along Y, and they'll be starting from 0 to what? Yes, from 0 to 2. So what that requires you is to now say, okay, our formula will be 2 pi from C to D, which we called case 2. Okay, what comes this side? Someone to just give us that formula to see if you are following.
X. X. Then square root of 1 plus x prime.
Okay, nice. It will be x root of 1 plus x prime, we square, then dy. Because look, your limits are in terms of y. So this your x should be.
For real? Oh, I hope my mic is off. No, it's not.
It wasn't 4. Okay. So you expect that this your x is what? G of y. Okay. So that requires making x the subject from there, right? This was a very nice question. It's not direct like the one we had. So you have to do some thinking here and see that your x here should be in terms of y. So therefore I need to make x the subject. Okay. But notice that your original function is in the first quadrant. So your x is from 0 to root 2. So you expect that your x is positive. So as I am making x the subject, we know that given that x squared is equals to y, okay, what does that mean? X is plus or minus root of y, right? But we already know that our x in this, on the interval we are having our arc length will start from there to there, by the way. So this is our arc length from there to there. We know that x is positive there. So which implies that in this case, x is just root of y, since x is positive in the first quadrant. Okay, since x is a member of, if you like, 0 to root 2. So x is positive there. You don't expect a negative value. Okay, so therefore, now we go back to our formula, and we may also want to find x prime. So what is our x prime in this case? Same applies. We are having the same function we had in the previous question when we make x subject. So that would be just, that would be our x prime. It follows that 1 plus x prime squared. I want to skip that stage. It will just be the same thing. 4y plus 1 divide 4y, right? Because this is the same thing we are from doing in the previous one. And it also follows that the root of 1 plus x prime squared is Again, I want to think in the same way, and that would be just the root of that, which will just be this one. Because that root is all the way there. Okay, therefore, our area that we are requiring is going to be 2 pi integral from C to D. Our C to D there is 0 to 2. And then what is our X? This our X we have said is root Y. Then this whole thing is this part. So I'm having root of 4y plus 1 divided by 2 root of y dy. Same integral, that and that and that goes. Okay. So meaning our area is now going to be
haven't finished copying the
0 to 2. All right, I'll come back to it. Okay, this part. Aren't you done? Or you could take a screenshot of this so that we don't waste time.
Okay, I've taken, thank you.
Okay, again here, we already know the integral of this. I'm not going to repeat the same procedure unless someone has a question. So we already know the integral of this guy. Okay, that will just be pi over 6, 4y plus 1 raised to the power 3 over 2. Okay, so from 0 to 2. This is because this is the same integral we had. The only difference is we are having y instead of x. So use the same technique to evaluate that. So then we take our upper limit minus lower limit. We put a 2 here. That would be 4 by 2 is 8 plus 1, that would be 9. So I can factor out this, and then I do upper limit minus lower limit. So upper limit, I put 2 here, that would be 9. So I'm talking of root of 9. Then I raise this to the power 3 minus, I put a 0 here. That would be only 1. Square root of 1 raised to the power 3 is simply 1. So what we are having therefore is pi over 6, and then root of 9 is going to be 3 raised to the power 3, is going to be 27 minus 1. 27 minus 1 is going to be 26. So divide 6 into 26. Or we can say 2 into 6 is 3. So pi over 3. 2 into 26 is going to be 13. So when you write this nicely, is 13 pi over 3 units squared. So that would be our resulting area. Okay, any questions? Okay, no questions. So we can try to answer if there's anything from the tutorial sheet that pertains to what we are doing. So let me try to.
Sir.
Go ahead.
So on which questions can be what's this? Can be required to use case 3 and case 4? How can you that these questions I can use case 3 and case 4?
Okay, that is when you are rotating about a certain line, not x equal to 0 or y equal to 0. So if I'm rotating about a constant, say x equals to maybe 2, then I'm using case 4, right? If I'm rotating about the line, let's say y equals to, so these are the cases that you're talking about. So look, if I'm rotating about y equals to 0, this is what we are calling to say, that would be the x-axis. So you use case, by the way, this can even work generally. Okay, even if I'm rotating about the line, the x-axis, that means I'm rotating about the line y equals to 0. So my k is 0. So I put 0 here. I'll have the formula, which is case 1. So this is actually, these are the general formulas, if you like to call them. So if I'm rotating about the x-axis, then I'm rotating about the line y equals to 0. So I use this formula. About the line x equals to n. So if x is 0, then I'm rotating about the y-axis. Okay, so to be precise with your question, you use case 3 or 4 when you are rotating about a constant, not 0. Okay, let me see if I can pick a question from tutorial sheet. So those were exam questions. Okay, so tutorial sheet. So we are almost done with tutorial sheet 5. So that should be question. So find the area of the, because we ended on question 9. Last time we finished question 9. So we are going to question 10. So look at question 10. Maybe we can solve one more today before the meeting ends. So find the area, question 10, find the area of the surface of revolution generated by revolving the curve x equals to y to the power 3 from y equal to 0 to y equals to 1 about the x-axis. So again, there you are rotating about the x-axis, which is y equals to 0. So you're using case 1. So I think I'm running out of paper. Okay, so you can be interpreting what that question is as I'm getting a paper. So generally what we can get from question 10 is that we are revolving the curve y equals to y, x equal to y to the power 3 from, so if you like, you can say y is a member of 0 to 1. So that's the arc you are using from 0 to 1. So we rotate that about the x-axis. So I think this time around, there is no need of us starting to sketch, right? if we have understood these things. Okay. So that is tutorial sheet 5 continued. So we're on question 10. So question 10, we have x equals to y to the power 3, and the arc length is measured from 0 to 1, and we want to rotate it about the x-axis. So if you like, you can say you are rotating it about y equals to 0. It's the same as x-axis.
I thought she just
Guys, I'm ending the meeting. This has been disconnected. Just remaining with less than 8